Good morning, friends. Myself Chandu Potangale. Since last few days, I was busy with the other work, but don't worry, we will be completing the remaining syllabus. Today, we are going to learn relationship between KP and KC. Between KP and KC. So what is KP? KP is the equilibrium constant when the concentration is expressed in the pressure, and KC is the equilibrium constant when the concentration is expressed in the moles per liter. Right. Now today we are going to learn about this. Right. So let's consider the general reaction. As we know that number of times we have learned this reaction. A moles of A gas plus B moles of B gas reacts with, since it is the equilibrium reaction, we write the double headed out. It produces C moles of C as a gas plus D moles of D moles of D as a gas. Right. Now we know that how to write the equilibrium constant for this reaction, that is Kc is equal to product divided by reactant raised to the power of the number of moles. Here product are C mole of C raised to the power C multiplied by D mole of D divided by reactant, that is concentration of A raised to A concentration of B raised to B. Right, we know that. Now in this equation, let's consider this is equation number 1. The concentration of the species are taken dimensionless by dividing the respective concentration in moles per liter by 1 mole per liter, which is defined as the standard state. I'll repeat. The concentration of species, the concentration of these species are taken dimensionless by dividing the respective concentration expressed in the moles per liter by 1 mole per liter, right, which is in the standard state. Now if the gas phases are there, we know that gaseous reaction, ideal gas equation, that is PV is equal to nRT. This is the ideal gas equation, we know that. Now where P is the pressure, V is the volume, right, N is the number of mole, R is the molar gas constant, and T is the temperature. Right, if I write this P is equal to N RT divided by V, again I can write N divided by V into RT. Now this quantity N divided by V, N is the number of mole divided by volume, that is moles per volume, that is moles per liter. We can say that moles per liter. Therefore this is in the concentration. Ideal gas equation can be written in the form of concentration, right? Therefore P is equal to CRT. N by V, that can be concentration, right? CRT, where in which P is expressed in the bar. Unit of P is bar. Unit of C concentration is, as I told you, that is mole per liter, right? R is molar gas constant value, that is bar per liter per degree Kelvin per mole, molar gas constant value, right? T is the temperature, as we know that, always expressed in the degree Kelvin, right? And V is the volume, that is expressed in the liter in this equation. V is the volume, that is expressed in the liter, right? Now let's consider this equation number as a 3. Substitution of this equation number 3 in equation number 1, what we will get? We will get that Kc is equal to, substituting equation 3 in equation 1, equation 3 in equation 1, what we will get? Kc is equal to Pc divided by RT raised to C PD divided by RT raised to D divided by PA divided by RT raised to A PB divided by RT raised to B small b, right? So how we have written this equation can be rearranged. This equation can be rearranged. How it can be rearranged? According to this equation, PC pressure of C. Let's consider this PC pressure of C, that is PC, is equal to what? Is equal to CRT. CRT. If I express this C, then that can be C is equal to P divided by RT. If I taken for the C, then that is equal to PC divided by RT. If I taken for the D, then that will be equal to PD divided by RT. That's what how we have taken. And number of moles are again they are the same, right? Where in this equation, let's consider this equation number 4. Where in this equation the partial pressures of species can be made dimensionless by dividing the respective term by 1 bar. Since it is the pressure, the partial pressure of this species, all these are the partial pressure. When we consider this as a concentration, then we can say that it is concentration, but whole mixture is there. If the reaction mixture is there, if it is the gas, then we can say that the concentration is in the partial pressure of gas A, gas B, gas C, gas D, etc., etc., right? So the partial pressure of these species can be made the dimensionless by dividing the respective pressure by 1 bar, respective partial pressure by 1 bar, and it is defined as the standard state. Therefore, that is Kc is equal to Pc raised to C, that is partial pressure of C, then PD raised to D, that is partial pressure of D, divided by PA raised to A, PB raised to B, that is this is partial pressure. When it is divided by 1 bar, that this quantity, that PA, PB, PC and PD, that will be equal to 1. Therefore, divided by RT, 1 divided by RT raised to C plus D, raised to C plus D, because this is divided by this quantity divided by 1 bar. This is divided by 1 bar, considered as 1 bar, partial pressure, that is equal to 1 divided by RT, 1 divided by RT, 1 divided by RT, 1 divided by RT. Therefore, if the base values are same, then addition of the power. Therefore, C plus D. Likewise that 1 divided by RT raised to A plus B, right? Therefore, this equation can be written Kc is equal to Kp into, if I take this is the upper side, that is equal to RT भागिले उलट गुणिले RT raised to A plus B, RT raised to A plus B minus C plus D, because the base value will be same. Therefore, addition of the power, in this case this will be negative value, this will be positive value, since this term is in the divided form, right? Therefore, Kc is equal to Kp, we can write Kp into RT raised to minus delta n. Why? The product is in the negative sign, therefore minus delta n. This can be written Kc is equal to, Kp is equal to, I'll interchange this one. Kp is equal to Kc into RT raised to delta n. Why delta n? this Kp will be divided by, therefore this Kc will be again divided by this equation, and rearrange, if I rearrange this equation, this minus sign will be positive sign, right? So where this delta n is what? Delta n is equal to number of moles of product, number of moles of product, number of moles of product, number of moles of products minus number of moles of reactants, right? Number of moles of product minus number of moles of reactant, where Kp and Kc are the dimensionless. In this equation, let's consider this equation number as a 5. Here in the Kp and Kc are the dimensionless. The RT also dimensionless. RT value is also dimensionless, that can be made dimensionless. Therefore, this RT value is equal to, we know that value of R 0.0831 K raised to minus 1 T raised to delta N. K is what? K is unit, right? K raised to minus 1 T raised to delta N. Therefore, this equation becomes Kp is equal to, therefore this equation, that is Kp is equal to Kc into 0.0831 K raised to minus 1 T raised to minus plus delta M. I'll write again, that is Kp is equal to Kc into 0.0831 per degree Kelvin temperature T, that is in the degree Kelvin. This is unit of this per degree Kelvin raised to delta N. This is the relation between Kp and Kc. When we express concentration term, if you want to express this Kp pressure in the form of equilibrium constant, that has to be multiplied by this value, that is molar gas constant value, multiplied by temperature raised to the power delta N. This is the relation between Kp and Kc. Next time I will be posting the video of molecular interpretation of equilibrium constant. If you don't understand, you have to watch this video again and again. Since we are not in the offline mode, you cannot ask me the questions, right? So let's try to learn the things. Till then, bye bye. Enjoy the lockdown.